Hi guys, and welcome back. So another brand new topic for you today, but we are jumping all the way ahead to section 12.2 in the textbook, because now we're finally going to start talking about surface area and also this thing called lateral area, which is different. We'll get to that in a little bit. Well, actually, pretty much right now. Basically, when we talk about anything lateral, like lateral faces, lateral area, it's everything that doesn't include the bases. All right. So if you have work with me here. If you have a can of soda, right, or a can of soup, the lateral face, quote unquote, or the lateral area is just what's all the way around. Like if you have a cardboard box that's standing up, it doesn't include the top and the bottom. So it's everything all the way around. Like right here, it's these 5 rectangular faces all the way around, not including the actual pentagon bases. These rectangles are your lateral faces. These are the lateral edges, just the vertical ones, because those are the only places where the lateral faces intersect. Up here, this would be the intersection of a lateral face and a base. So that doesn't count, all right, as a lateral edge. This would be, here, I'll put that in, a base edge. Because here it says the lateral faces intersect the base edges. All right. The altitude, I think you guys have seen altitude before. I think you guys are familiar with that. The altitude is a perpendicular segment that joins the planes of the bases. The length of the altitude is the height. So you still have to have that perpendicular altitude or height in order to deal with any of this. All right. So when we talk about how to find the lateral area, again, it just deals with the faces all the way around, all right? So the formula for the lateral area of a prism that you are going to have to know is it's the perimeter of your base times the height of the whole figure, all right? Not the height of the base, the height, the three-dimensional height of the actual prism itself, all right? That's how you would find lateral area of a prism. So when we're given something like this, it's actually a lot easier than it looks because, again, all it's asking for is the lateral area, which is just the perimeter of the base times the height. So since this is a regular hexagon and we have the side length of the hexagon, we can easily just multiply 5 times 6 to get the perimeter of the base, which is 30. And then this height of the prism right here is 12. So it's just going to be 30 times 12, which I'm blanking, so I'm just going to do that on my calculator. No. Okay, 360. So the lateral area is 360, don't forget units, centimeters squared. It is centimeters squared because, again, it's area, all right? Area, if we considered the lateral area, again, all the way around, if we consider that, it's kind of like the label on your soda can or can of soup, right? If you unfurled or if you took the label off a can of soup and you flattened it out, it would be a piece of paper. And a piece of paper is in 2 dimensions. So 2 dimensions means that we're going to have units squared, all right? Once we get into volume later on in the school year, that's when we're going to deal in units cubed. All right, so don't get too ahead of yourselves. But that's, I think, all I have for the lateral area of a prism for right now, because surface area includes the bases. All right, it's basically what we just did before with the lateral area. It's the lateral area plus the area of both your bases. So since we have 2 bases here, that's why, hold on. That's why the formula for the surface area has it as 2b, all right? Because we do have to take into consideration the area of both bases. But since the bases are congruent, you don't have to find the area of each separately. You can just find the area of one and then multiply it by 2. A lot of the times, you're also going to see it looking like this, where you have the lateral area formula written out, all right? I think this is the one that I'm going to be using, this pH times 2b. And I think that's the one that you should see more often. I know you would definitely see it more often if we were still physically present in school. But yeah. All right. So I'm going to keep that off to the side for my reference. But for the surface area, all right? Surface area is now the lateral area plus 2 times the area of the base. So it's going to be PH plus 2B. All right, so perimeter of the base, we have this square right here. All right, so the perimeter of the base is going to be 6 times 4, which is 24. H is your height of your entire prism. Sorry, just had to take a quick pause for a second. Just because I ended up looking at a couple other things, and a lot of the times, you know, surface area I know can kind of get a little complicated, depending on what you consider your base of the figure, all right? A lot of the times, you know, it's kind of like what we were just starting to talk about, you know, these squares, right? But also a lot of the times, it's the, you know, it's whatever's like resting on the floor, you know, like you're used to with the base and the height of two-dimensional figures, all right? So you're definitely more than welcome to like ask if you have concerns or questions about that. But I actually just went into the textbook to make sure this is going okay, and it is, all right? They do consider these squares the bases, so we're going to go right back into the perimeter of 24 and using this 12 as your height, all right? And then because we're considering these squares our bases, this is going to be plus 2 times the area of the base, which is 6 times 6. All right. I really think you have to be more careful about this with lateral area because lateral area leaves a few sides out. With surface area, even if you considered something else or some other pieces your bases, because it encompasses the entire figure, I do think if you did this a little bit differently, you still should get the exact same thing when you add this all up. So 24 times 12 is 288, plus 2 times 6 is 12, times 6 is 72. So this is going to be, wow, 360, again, centimeters squared. I swear that wasn't intentional. And it's still centimeters squared because it's area. Okay? This prism, like, you don't have any options for what your bases are. You know, like in the hexagon we did last time, we knew the hexagons were our bases. We know the triangles are our bases here because those have the same faces. You know, everything out, or those have the same shape. Every other face on this figure is a rectangle. So the triangles are what we're going to deal with as our bases. Let's see here. We are actually going to have to do a little bit more work to figure out what the perimeter is going to be because it doesn't say that anything about this being regular. So here's where I'm coming from. All right. What I'm thinking is that, all right, we know the perpendicular splits this into 6 and 6, right? 6 and 8 are 2 parts of a Pythagorean triple, right? 6, 8, 10. So that means the other 2 sides are going to be 10, and then the perimeter of the base is going to be 12 plus 10 plus 10, which is 32. I'm going to write that down. Okay? And then the height is, again, going to be this exact same height over here, so 10. Plus 2 times, well, now we have, we're dealing with triangles. So we know the formula for the area is 1/2 base times height. So this is going to be 1/2 times 12 times 8. And the nice thing here is that the 2 and the 1/2 end up canceling out. So now we just have 320 plus, what's 12 times 8? 96. So the surface area then is going to be 416 units squared because we don't have any units here this time. All right, so there's that one. All right, now we have to do both. All right, this I think is the most complicated this problem is going to get. All right, or these kinds of problems. So lateral area we know is perimeter times height. We have that the base is a pentagon. It's a regular pentagon because of all the tick marks. So the perimeter is going to be 6 times 5, which is 30. Oops. The height, then, is the height of the actual prism itself. So it's this 5 right here. And 30 times 5, the lateral area is 150 inches squared. So the nice thing about doing surface area for this same problem is that we already did plus 2b. We already did the lateral area portion of it. Okay? So we can honestly just take that 150 and carry it over and not do any of the same work all over again. All right? So plus 2 times, how are we going to find the area of the base? Well, since this is a pentagon, it's a regular pentagon, this is where we're dealing with that 1/2 times the apothem times the perimeter business from the last chapter. All right? So we know, 1/2, we know the perimeter is 30 like it was before. And then this is actually the apothem. It's not that much work, not really any work at all to get there because we have it given. So times 4.1. Same thing as before. The 2 and the 1/2 cancel out. I think that does happen a lot with these kinds of problems. So this is 150 plus 30 times 4.1 is 123. So the total is 273 inches squared for the surface area. Because the surface area does encompass more of the figure, you should expect to get a larger number for the surface area. If you don't, you probably did something wrong. All right? So, really quick, just with cylinders, and this is also true for prisms. Well, the axis of a cylinder is the segment with endpoints that are the centers of the circular bases. So right here, from the center to the center, that's the axis of the cylinder. All right? If the axis is also an altitude, so if the axis is perpendicular to the bases, then the cylinder is a right cylinder. If the axis is not an altitude, then the cylinder is an oblique cylinder. Real talk, I don't think we see that vocabulary too much, but the point is your height, as always, or your altitude, still has to be perpendicular to the base, all right? If it's not, you're probably going to have to do a little bit of extra work to get there. And the same thing is also true of prisms, all right? But if you really sat and thought about it, a cylinder is kind of just like a prism with a circular base, sort of. All right? So we can still use a similar lateral area is the perimeter of the base times the height idea for the lateral area of a cylinder. Because the lateral area of a cylinder is 2 pi r h. And 2 pi r should probably sound familiar because it's the formula for the circumference of a circle. And circumference is just the perimeter of a circle. So it pretty much comes from the exact same place. It's just a little bit different because we're dealing with cylinders now instead of prisms. It's actually, all of it's actually right down here. I just noticed that. The lateral area is 2 pi r h, and then surface area is the lateral area plus 2 times the area of the base. And again, it looks a little bit different because we're dealing with circles now. So it's 2 pi r plus 2 times pi r squared for the surface area of a cylinder. Because again, the bases are circles this time. All right? So, find the lateral area and the surface area of the cylinder. Round to the nearest tenth. So, actually, I'm going to keep this one off to the side too, just for my reference. So lateral area is 2 pi r h. And luckily we have all that information given to us, so it's pretty straightforward. 2 pi times the radius, which is 14, times the height, which is 18. So you have to read carefully. I noticed this a lot with the last check, that you really have to read carefully in terms of like rounding stuff, units, and also exact answers. There were a bunch of people who got half points taken off all over the place because they didn't follow directions and didn't leave exact answers. If you were asked to leave an exact answer, I would expect to see pi in there. So 2 times 14 times 18 is 504. So this would be 504 pi feet squared for the exact answer. This question does say to round off to the nearest tenth, so we can multiply this by pi. If you get something like this in your calculator, I think it's this button down here will give you an exact, yeah, all right, that gets you the decimal approximation. So the decimal approximation rounded up to the nearest tenth is 1583.4 feet squared. All right. So surface area now is 2 pi RH plus 2 pi R squared. I'm going to leave this exact just because if we use the rounded off decimal, it's probably going to mess us up a little bit. So I'm going to bring in the 504 pi and then round it off again at the end and then do plus 2 pi times 14 squared. So 14 squared is 196 times 2 is 392. So this is 504 pi plus 392 pi. You can combine these because they both have a pi. I did see that a little bit on the last check as well, where people were doing, like, if it was like 64 plus 8 pi, I don't think that was an answer, but you know what I mean. If it was 64 plus 8 pi, there were a lot of people who would combine that into, like, 72 pi. Doesn't work. That doesn't work because they both don't have a pi attached. You know, like if you had 2x plus 5, you wouldn't be able to combine that because they both don't have an x on it. It's the exact same thing. This, though, we can work with because they both do have a pi attached. So 504 plus 392 is 896 pi. And again, converting that over to a decimal is approximately 2,814.9 feet squared. Okay? Find the diameter of a cylinder if the surface area is 480 pi square inches and the height is 8 inches. All right, so we're going to go back to our surface area formula, which is 2 pi r, 2 pi, oh my God, I can't write, 2 pi RH plus 2 pi r squared. All right, so what do we know? We know the surface area is 480 pi, so we're going to plug that in. We know the height is 8, so we're going to plug that in where we can. 2 pi times r times 8 plus 2 pi r squared. So 2 times 8 is 16. This should be an equal to. All right, now what? We're going to have to try to solve this for r. So it sort of looks like we're going to have to factor at some point. So let's see if we can like get rid of some stuff before we do that. The pi's are going to cancel out. So we have 480 is 16r plus 2r squared. That looks a little bit nicer. But to make this even nicer is we can divide everything by 2. Kind of like take out a GCF, you know? So this is r squared, this is 8r, and this is 240. Yeah. All right. So if I just kind of rearrange some stuff, this is going to be 0 is equal to r squared plus 8r minus 240. So now what we have to do is figure out what are factors of negative 240 that add up to 8. So I feel like we've done stuff like this before where it's probably going to take a long time. So I'm going to pause this again, come back. Yeah. All right. So it looks like this is it. 20 and 12. All right. Because we want positive 8 and 20 minus 12 is 8. So this is going to factor into r plus 20 and r minus 12. So when you solve this, you get r is equal to negative 20 and positive 12. All right. Now, sorry, I'm losing my train of thought. We've done stuff like this before, where if you're talking about a length, it's got to be positive because a negative length makes no sense. So if you're saying r is your radius is negative 20, no, that's not possible. All right. The only possibility for our radius then is going to be 12. But you have to be careful. Go back to the original question. it's asking us for the diameter. So basic circle stuff, diameter is twice the radius. So the diameter then is 24 inches, because that's the units that we were given. And that's the entire problem. Is that it? That's it. Sweet. All right. So your homework today is probably going to be a little bit more complicated than it was last time. Kind of is what it is with all the area stuff, or surface area, lateral area, etc., etc. But you guys know where to find me if you need any help, if you have any questions, and I will talk to you guys very soon.